there!
I'm Dante.
I'm Matt.
I'm Thomas.
And this is Dynamics.
So Matt, what is dynamics?
Dynamics is a study of why things move.
So force is what makes things move. This can either be a push or a pull. This is usually measured in newtons.
Force is gravity.
Or a pulley down force. This force, gravity, pulls everything down to the surface of the earth and is always there. To find this, you take the mass.
Everything has mass. Mass is how much stuff is in a thing. For instance, this ping pong ball does not have as much mass as Dante.
So Matt, what's mass measured in? Like pizza slices?
No, Dante! It's measured in kilograms.
To find the force of gravity acting on the thing, you take the mass of the thing, you take the pulley force,
Which is 9.8 newtons per kilogram.
and you multiply them together.
An example of gravity would be me dropping my man skills book, like so. So Matt, what's keeping us from falling through the ground? Is it meatballs or something like that?
You know, I really don't think it's meatballs. Maybe, we should ask Thomas about that.
Okay, because I was just thinking.
Yeah, well...
No, it's not meatballs, it's the normal force. The normal force is the force that keeps you standing on the ground. When you're on the floor, the normal force makes it so that you stay there instead of letting the pulley down force pull you down. If there was no normal force, I'd be doing this. Dante, what causes an object to move that's not the normal force or the gravitational force?
The applied force is the force being put onto an object that usually makes it move. So, for example, if I take my man skills book and put that on here and I push it with my hand, the applied force is my hand acting onto the book, making it move. So Tom, what's the frictional force?
The frictional force acting against the applied force when an object is on the surface of the earth. As long as you're on the earth, the frictional force will always be there when an object is moving. Or not moving. There are two types of frictional forces. There's static frictional force when an object is at rest, and there is a kinetic frictional force when an object is moving. No, you're not supposed to. For example, when I drag Dante's body across the floor, the frictional force acts against the applied force. In this case, the applied force is me pulling, and the frictional force is acting against it. The frictional force also acts on an object in the air. It acts against the gravitational force. This causes the object to slow down in the air and not fall as fast as we do.
So Tom, how do we visually show all the forces acting on an object?
To visually show all the forces acting on an object, we draw free body diagrams. For example, we will draw a free body diagram for this man sitting on this rocking chair, who shall not be named for privacy reasons. First, we draw the object.
Next, we draw all the forces
Acting on the object.
Finally, we label the objects and write the mass.
Wait, Dante, so are there rules with physics, or can I just do whatever I want?
Of course there are laws, and of course there are rules. So this guy named Sir Isaac Newton, a long time ago, came up with 3 major laws. And the first one is, if no force is around a thing, the thing won't move. Or it will move in the same speed in the same way, if nothing is stopping it.
For example, because there are no forces acting on the guy in the rocking chair, he is at rest.
Dante, it says here that there's more laws.
Well, yeah, I said that there were 3.
Oh, okay. Well, the second law is that if the force on a thing is bigger than the other force, the thing will speed up in the same way as the applied force.
An example of Newton's second law is that if I take an object, like the man skills book provided, and I put this on the table, and I apply a force, the object is going to speed up, like so.
So Newton's third law says that for every action force, there's a reaction force going the other way. For example, my buddy Zach here is going to jump off the ground. The action force is Zach's legs pushing against the ground. The reaction force is the ground pushing Zach upwards. This is also known as an action-reaction pair.
So there's also something called tension, and Matt will explain what that is.
Alright, tension is when things are stretched. It happens in ropes and cords. But we don't really like tension, so for now we're gonna ignore it.
So, for example, since tension is found in ropes and cords, when me and Matt pull on it, the force is only a pulling force for both of us, not a pushing force. No, it's mine! I got the rope!
Hey there! Hey there! Hey there! Hey there!
Mass is how much stuff is in a thing. For instance,
Wait, Matt, what's So, Matt. So, Matt, what's this? What? So, Matt.
he's laughing.
So, Matt, what's keeping us from like falling through the ground? Is it like meatballs or something like that?
You know, I really don't think so, Dante.
So, Matt, what's keeping us from falling through the ground?
You're supposed to say meatball.
For example, when I jump, you have to try and move. I'm supposed to say pull.
This is the force that's frictional force always. Oh crap! Frictional force. The frictional force can. The frictional force. Oh. There. Oh no! I.
This is when all the forces are acting on the object. Alright, so there's something called tension, and Matt will explain what that is.
Tension is when things are stretched.
No, we do that. You have to catch it.
I did!
For example, since tension's only found in ropes and cords, when we pull against each other, then...
Oh, it's blurry. Hold on. Go again. 3,